You should be ready to check your answers to the warm-up. Well, it said to divide, so that means we're using synthetic division here again. So we're going to put the opposite of what is in the parenthesis in the box. So we have -6. Now let's check to make sure we're not missing any exponents. We have 4, 3, 2, 1, and none. So we're good to go there. So we write our coefficients. We've got 1, 11, 33, 24, and 32. Remember, we always bring the first one down, and then we multiply and add, multiply and add. So 1 times -6 is -6. Add 11 and -6, we're at 5. 5 times -6, we're to -30. Add those together gives us 3. 3 times -6 is -18. 24 and -18 make 6. 6 times -6 is -36. This leaves us with the -4. Remember, when we do write our new polynomial, using these coefficients, we start with the 1 degree less than this one. So that means we're starting with an x cubed. So we have 1x cubed, or just x cubed, plus 5x squared, plus 3x, plus 6. And then you could either put a remainder of -4 or -4 over x plus 6. And there's your answer to number 1. Number 2, in the box we put the opposite. Since it's a -1, that means we're going to put in as a +1. We check to make sure we're not missing any exponents. We have a 3, 2, 1, none, so we're good. So we have 4, -9, 9, and 3. Remember, first term always comes down. And we multiply and add through, so 4 times 1 is 4. Add -9 and 4, we're looking at -5. -5, multiply it back to 1. Add those together, we're at 4. 4 times 1 is 4. 3 plus 4 is 7. And again, we always start with an exponent 1 less than the highest, so that means since it was an n cubed, we're starting with an n squared. So 4n squared minus 5n plus 4, and then plus our remainder of 7 over n minus 1. That should have been pretty much review, because again, you were just tested on this. Today we're going to use the remainder theorem to find possible roots and then to find actual roots. So we have what we call the rational root theorem, which says we're going to find all the factors of the lead coefficient we're going to refer to that as the LC. And remember, it's the coefficient to the highest exponent. And we're also going to find factors of the constant term. Remember, the constant term is the number that's all by itself. We're going to divide factors of the constant term by the factors of the lead coefficient, the LC. And that will tell us all of the possible roots that could exist. Not any actual ones, but the ones that we know could be a possibility. So, the first thing we need to do are find factors of the constant. So here's our problem. x cubed minus x squared plus 2x plus 5. Well, the constant term in here is the 5. Well, what are factors of 5? I'll put that here, the constant's 5. Well, you know that it's 1 times 5. But it could also be a positive or a negative. So plus or minus 1, plus or minus 5. Sometimes there'll be more, but for right now that's it. And then we find the factors of the lead coefficient. Well, the lead coefficient, we look at the highest exponent, which is x cubed. The number that's with x cubed is a 1, so our lead coefficient is 1. Well, what are factors of 1? Well, 1 times 1, so 1 is a factor. And again, it could either be a positive or a negative. Now we do the dividing part. So we take each factor of the constant and we divide it by each of the LC. Well, here, these we're just dividing by 1. So we have 1 divided by 1, which is 1. And again, that's plus or minus. And then we have the second one, which is 5. Divide that by 1, and that is plus or minus 5. These numbers will always have the plus or minus in front of it. So our possible roots are a positive and a negative 1, or a positive and a negative 5. Now, to find a rational root, we do this after we find our possibilities. So step 1 is after we found our possibilities, which we did in the first example. We're going to use synthetic division. To check the first option to see if, when you plug it in, if you will get 0. 0 tells us that it divides evenly into it, so that's what we're looking for. When the remainder is 0. So above this, I'm going to write remainder. And we're going to continue using synthetic division until we find p of x equals 0 for one of those possible roots. So our first example, the first thing we're going to do is we're going to edit this. Instead of x cubed, we're going to make this 15 x cubed. So add that onto your paper, please. What is a rational root of 15 x cubed? Well, the first thing we look for are factors of the constant. So our constant here, we look all the way through it until we get to the number all by itself, which is a 2. Well, what are factors of 2? 1 and 2. And again, we always put plus or minus. Then we look at our lead coefficient. Well, the highest exponent is the exponent of 3. So the number that goes with that is 15. So what are factors of 15? Well, we know 1 and 15, and also 3 and 5. And then we put plus or minus in front of each of them. So before we can actually find a rational root, we have to list out what your possibilities are. And remember, to find the possibilities, we divide each factor of the constant by each factor of the lead coefficient. So our first one would be 1 over 1, which is just 1, and remember always plus or minus. And then we do 1 over 3, which would be 1/3 plus or minus. Then we still have 1 over 5, because again, we're doing it to each one of these. So that would be plus or minus 1 over 5. and then we have 1 over 15. So plus or minus 1 over 15. So that takes each one and sends that to each of the lead coefficients. So now we move to the other factor, which is 2, and we do the exact same thing. Now, if any of them happen to be the same, you wouldn't need to repeat it. Once it's written there, you don't need to repeat any. So we have 2 divided by 1, so that's plus or minus 2. Then we have 2 divided by 3, so that's plus or minus 2 over 3. Then we've got 2 divided by 5, so that's plus or minus 2/5. And then last but not least, 2 divided by 15, so that's plus or minus 2 over 15. So here are all of my possibilities. Now, if you're only asked to find a rational root, then my recommendation would be to not check the fractions, because those are going to be time consuming, and you can use your whole numbers. So the first one we're going to check is the positive 1. So we look at our factor here, our factored root that we're looking at, which is x cubed. So I check there's an x cubed, x squared, x, and no x, so we don't have any missing terms. So we have 15, negative 32, 3, and 2. So as soon as you get one answer with a remainder of 0, you found your actual root, because all it asks for is what is a rational root. So we bring the 15 down. 15 times 1 is 15. Add that to negative 32, we're looking at negative 17. Multiply negative 17 times 1. Add that to 3. Negative 14 times 1 is negative 14. Negative 12. Did it have a remainder of 0? Nope, which means it is not 1. So that was the positive 1 we checked. Now I'm going to check the negative 1. We know that our coefficients on top are going to stay the same. (15) times negative 1 is negative 15. Add those together, and you're at negative 47. Negative 47 times negative 1 turns it to a positive 47. Add those together, you're at 50. Well, pretty much at this point, you should be able to tell that your remainder is not going to be 0, so you could go ahead and stop, but we're going to go ahead and finish this out. 50 times negative 1 is negative 50. Gives us a remainder of negative 48. Not what we want. So I look at my other possibilities. Again, there's not really any reason to do the fractions, because you don't need to prove if those are the roots. You're just looking for a root. So I would jump all the way to the 2. Now, if the 2 didn't work out, you would have to do fractions, but try to avoid that as best you can. So we start with the positive 2. So we know our coefficients are going to be 15, negative 32, 3, and 2. And remember, we're looking for when we get a remainder of 0. Bring down the 15. 15 times 2 is 30. We're left with a negative 2. Negative 2 times 2 is negative 4. Add that to 3 gives me a negative 1. Negative 1 times 2, which gives us a remainder of 0, which means x equals 2 is a root. So that one took us 3 tries to find an actual root. It could take you more, it could take you less, but again, you generally want to avoid the fractions unless you don't have a choice. Tomorrow we're going to be building on this next part here, so today we're just staying nice and easy with it. So we're going to use a conjugate root theorem to identify additional roots. Well, conjugate, we saw this back with imaginary numbers, and it was kind of like the opposite. Well, we use conjugates in only certain cases. And the cases are anytime we have a radical, which is again the square root symbol, or a complex number, which contains the letter I. If you have either one of these or both of these, then you must have 2 roots, not just 1, 2, the positive and the negative. So even if they only give you 1 root, you know that they're going to have another root. So our first example says that the current roots are the square root of 2 and 1 plus I. Well, since we have a radical, we know we have an additional root. So if square root of 2, then that means we have the negative square root of 2 as well. Well, 1 plus I, that's a complex number, so we also have an additional root for that one, and that would be 1 minus I. Remember, we changed the complex part, not the regular number. And there's your 2 answers. And again, this is what we're going to be building on in class. Last problem of the day, we have a u-try. So this time, our roots are the square root of 5, 1/2, and 7 plus 2i. And they want to know if or what any additional roots that could exist. So go ahead, take a moment, think if there would be any additional roots, and write whichever ones you think down. Check with the neighbor, see if you agree, and then unpause this to see if you are correct. Alright, well, this one had a bit of a trick to it, so let's see if you caught it. Remember, even though they gave us 3 roots, the only additional roots occur when you have a square root or the letter I. So I look at my first root, which is the square root of 5. Well, that has a square root, so I know I have to have the opposite. Since it's a positive square root of 5, it means I have a negative square root of 5. And then our next one is 1/2. Well, 1/2 isn't under a radical, and 1/2 doesn't have an I with it, so it's just like we pretend this doesn't exist. There is no additional root for that one, and that's the one we could have gotten picked up on. Now we then have 7 plus 2i. Well, that has an I with it, so there is an additional root. So if this one starts off as 7 plus 2i, the other one is 7 minus 2i. And there are your 2 additional roots. You have 5 questions for homework tonight. The first 3 is like the first problem we did. You're listing all possible rational roots. All possible, remember, is your constant. And your LC. Okay? 4 and 5, you're going to find a rational root. for p of x equals 0, which means you'll use your constant and your LC factors, and then you'll use synthetic division until you find the root that you're looking for. And that's what we did for problem number 2. So if you want, you can either take a picture of these 5 problems. If you have time, write them down, or know that you can go onto YouTube, look for my name, and then under my channel, look for this video, and the 5 problems will be on there.